Here today's topic that is gravitation. Here mainly that gravitation is of two parts. So the first one is here that gravitation is inverse square law of gravitation and variations of small g. This is coming under one phase. So inverse square law of gravitation and variations of small g. Next one is here planetary motion. That is a planetary motion is in the second phase, planetary motion. And here it is inverse square law of gravitation. So that's why it is F. And thereafter it is variations of small g. Variations of small g. So these are the two phases of that is gravitation. And in these two phases, first of all, we are coming to this inverse square law of gravitation. Inverse square law of gravitation means, so first the force in between two masses is directly proportional. The force in between two masses is directly proportional to the product of the masses and inversely proportional to the square of distance between them. So inversely proportional to the square of distance between them implies F proportional to m1 m2 by d square implies F is equal to capital G m1 m2 by d square is that formula. F is equal to capital G m1 m2 by d square. This is known as inverse square law of gravitation. And the same inverse square laws they come even in electrostatics and as well as they come in magnetism also. So in electrostatics it will be F is equal to 1 by 4 pi epsilon naught q1 q2 by d square. In case of electrostatics it is 1 by 4 pi epsilon naught q1 q2 by d square. So here also that force is proportional to q1 q2 and inversely proportional to d that is d square is here, and 1 by 4 pi epsilon naught is a constant just like a capital G, it is also a constant. Next, similarly, F is equal to mu naught by 4 pi m1 m2 by d square. This is in case of magnetism. In case of magnetism, it is F is equal to mu naught by 4 pi m1 m2 by d square. Now you can observe this capital G is there and this capital G is a constant. So there are, even though all these are the inverse square laws, that is coming in gravitation here, and again this is coming in electrostatics, and again this is coming in magnetism. Even though all these are the inverse square laws, but this gravitational inverse square law is separated from the other two laws. This gravitational inverse square law is separated from the other two laws. How it is separated means, first of all, the common feature in all of these inverse square laws is all of them are inversely proportional to square of the distance between them. All of them are inversely proportional to the square of the distance between them. But here it is separated from the other two laws. Here that force can be either attractive or the repulsive. Here this force can be either attractive, in this case this is only the attractive force, but in this case these are attractive or the repulsive forces. So that's why here is attractive forces. Its meaning is in between two masses the force of repulsion is not defined at all. So that's why it is only the attractive force. Whereas in this case these are the attractive or the repulsive forces. Suppose in between two like charges or in between two like poles you can have force of repulsion. And in case of unlike charges and again the unlike poles you can have force of attraction. So it can be of anything. So that's why, but here it is only that attractive force. That is the basic difference from that which separates that inverse square law of gravitation from that other two laws. And similarly one more separation is one more point is also there, and that point is here this whatever that constant, that is a capital G, it is a constant throughout universe. It is a constant whatever may be the medium present in between two masses, but capital G is a constant. Suppose the values of the capital G are, this can be taken as 6.67 into 10 to the power minus 11 Newton meter square, and again kg power minus 2, because the capital G is equal to Fd square by m1 m2. So that's why F is Newton, d square is meter square, and kg power minus 2. And similarly, when you are coming to the CJ system, that becomes 6.67 into 10 to the power minus 8. And Newton, that will be taken as a dyne. And meter square, that can be taken as a centimeter square. And kg power minus 2, that can be taken as a gram power minus 2. So that's why 6.67 into 10 to the power minus 11 is here, 6.67 into 10 to the power minus 8 is here, and this is a constant whatever may be the medium that is present in between two masses. But here in this case 1 by 4 pi epsilon naught is applicable only for when medium present in between the two charges is air or vacuum, and for that 1 by 4 pi epsilon naught is equal to that is a 9 into 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9. Similarly, mu naught by 4 pi is equal to, that is equal to 10 to the power minus 7. That is equal to 10 to the power minus 7, and these are the values only in between two charges. Similarly, in between two poles, the medium present is air or vacuum. Instead of air or vacuum, if any other medium is present, then immediately this value will change. So in that case, you have to take that dielectric constant or that dielectric constant of that medium. Similarly, here also permeability of that medium you have to take, but in this case it is a constant everywhere, that is whatever with the medium that is present. So that's why the force in between two masses, that depends only on the, that is a magnitude of those masses, that is m1 m2 only, and again similarly it depends upon only that distance between them, but it is independent of this medium present in between them. So this is the capital G's, this is the value. And after that, now we are coming to that next point is inverse square, that is the intensity of a gravitational field. So inverse square of gravitation is over, and thereafter intensity of gravitational field. So intensity of gravitational field means here, that intensity of gravitational field means it is the force experienced by the unit mass. It is a force experienced by the unit mass at a point in that gravitational field. So it is the force experienced by unit mass. So that's why intensity of gravitational field varies from point to point. So from point to point, suppose some mass is there and its field is that is spread throughout this area, throughout this region, and suppose if you are taking that unit mass somewhere here, if you are taking that unit mass, that may be 1 kg or 1 gram, that is the force experienced by this unit mass at that position. So the force experienced by that unit mass is known to be, that is intensity of a gravitational field at that point. Why it is at that point? Because if you change the position of this 1 kg to some other position, that may be here, that may be here, then automatically d will change, then automatically intensity of gravitational field also will change. Intensity of gravitational field also will change. So in that case, intensity of gravitational field, that can be taken as, so that is taken as the capital G, and again m is taken and m2 becomes 1, and thereafter distance is r square. So that's why intensity of gravitational field is gm by r square. So this is the gm by r square is that formula. Similarly, you can see that that is the intensity of electrical field in this case, and again the intensity of that is a magnetic field. What you can take it, that is a magnetic induction. So magnetic induction in this case, and that is represented by capital E, and here it is represented by B. So here you can take it is a unit positive charge, and here you are taking it is a unit north pole, but in case of the gravitational field it is a unit mass, and here the same, that is the concept is same. The force experienced by the unit mass, here the force experienced by the unit positive charge, and here the force experienced by the unit north pole. So the force experienced by that unit unit mass placed at any point in that gravitational field is the intensity of gravitational field at that point only, So that's why I is equal to intensity of gravitational field is equal to gm by r square. So far what we have completed, that is inverse square law of gravitation, and that force of attraction only, it cannot be the repulsive, and again it depends only on the masses and the distance, but it is independent of the medium present in between these two masses. And thereafter we have came to this intensity of a gravitational field, and here how that inverse square law of gravitation, that is the attractive force, is separated from the other two inverse square laws which are coming in is electrostatics and again this magnetism, that is also completed. Now we are coming to this intensity of a gravitational field, and that is I is equal to gm by r square is here, intensity of gravitational field. Now we can define that neutral point or that null point. So neutral point. So neutral point means suppose here you are taking m1 is there, and again thereafter it is m2 is here, and here they are separated by a distance at d, and that is then now you are taking some point is here. So that point we can say it is a neutral point. Neutral point means how do you define that neutral point? That is in the combined gravitational field of two masses. In a combined gravitational field of two masses, the point where the resultant intensity of gravitational field is 0, that point is said to be neutral point. in the combined gravitational field of two masses, the point where the resultant intensity of gravitational field is 0 is known to be that neutral point. That is called the neutral point. Similarly, you can see that neutral point or that null point in case of that electrostatics and again the magnetism also. Now, in case of the electrostatics, in the combined electric field of two charges, the point where the resultant intensity of electric field is 0. Similarly, in magnetism, it is the point in the combined magnetic field of two poles. So, the point where the resultant magnetic field is, resultant magnetic induction is 0, that you call it is a neutral point. So, that is why neutral point is coming here. And in case of this neutral point, what you can take, yet neutral point here, these are the unequal masses and we suppose that is m1 less than m2. These are unequal masses and here we are taking m1 less than m2. At a neutral point, the intensity of gravitational field due to this mass and intensity of gravitational field due to this mass both are same. So, that is why what we can take I1 is equal to I2. Intensity of gravitational field due to this mass and again intensity of gravitational field due to this mass both are same. That is I1 is equal to I2. So, that is why just now I derived that formula I is equal to Gm by R square is that formula intensity of gravitational field. So, that is why here we are taking this is x is here and this can be taken as a d minus x is here. So, I1 is equal to this can be taken as the capital G and m1 by x square is here. Capital G m1 by x square. And here I2 is equal to capital G m2 by d minus x whole square is here. D minus x whole square is here because at a neutral point these are same in magnitude. So, that is why gm1 by x square and again here also next one it is taken a d minus x by x whole square is equal to m2 by m1 is equal to m2 by m1 and thereafter it becomes a d by x minus 1 is equal to root of m2 by m1 is there. And here d by x is equal to root of m2 by m1 plus 1. And thereafter that is the distance of that neutral point or that null point from that lower mass, from that smaller mass. So, here we have taken that is m1 less than m2 because we cannot take those two masses are same. If at all these are the equal masses, we need not find out that formula for this neutral point because it will be at exactly at the midpoint if at all these are the equal masses. Now, here these you have to take these are the unequal masses. Now, you have taken m1 less than m2. In this case, x is equal to d by root of m2 by m1 plus 1 is taken. So, this is the formula. X is equal to d by root of m2 by m1 plus 1. And in this case, you can observe, suppose in case of that electrostatics, it becomes x is equal to d by root of q2 by q1 plus or minus 1. Plus or minus 1. Similarly, if you are taking that is a pole strength, x is equal to d by root of m2 by m1 because those indicate to the pole strengths, they indicate that the pole strengths plus or minus 1 is coming there. Because here in that case the neutral point can be formed either in between them or outside also depending on the nature of charges. Suppose if at all these are of the like charges, in that case a neutral point will be formed in between them. These are of the unlike charges, then the neutral point will be formed outside of these two charges. So, that is why here x is equal to d by root of m2 by m1 plus 1 only because in between two masses repulsive force is undefined. Repulsive force is not defined, it cannot exist at all. So, that is why it is only the attractive force x is equal to d by root of m2 by m1 plus 1, it cannot be plus or minus 1.